Hello learners, welcome back. Let's explore the topic scientific methods in this session. Look at this scenario. A study finds that excessive social media use correlates with increased anxiety in teenagers. But is social media the cause, or do pre-existing mental health issues lead to more screen time? So how do scientific methods guided by the process of induction and deduction help us uncover the truth and bridge the gap between observation and theory? To know this answer, it is very essential to understand the concepts in depth. So let us proceed with the learning objectives. By the end of this topic, you will be able to explain the meaning of scientific methods.
For a method to be considered scientific, it must use evidence that can be observed and measured, following clear rules of reasoning. The scientific method helps minimize the effect of researchers' personal biases on results. Researchers may prefer certain outcomes, but these preferences should not affect the study or its conclusions. Sometimes people rely on common sense or logic and think testing isn't needed. Another common mistake is ignoring data that goes against the hypothesis. Let us understand the meaning of scientific methods. The scientific method is a structured process that scientists use to create an accurate, reliable, and consistent understanding of the world. It acknowledges that personal and cultural beliefs can affect how natural phenomena are perceived and interpreted. To reduce these influences, standardized procedures and criteria are applied. Ultimately, the scientific method aims to minimize bias and prejudice when testing hypotheses and developing theories. Clover and Basely define the scientific method as a systematic, step-by-step procedure following a logical process of reasoning. What are the key characteristics of the scientific method? Empirical, the scientific method deals with realities that can be observed through sensory experiences. It produces knowledge that is verifiable through observation or experience. Some realities, such as counting the number of students in a classroom or determining their gender distribution, can be directly observed. Others, like attitudes, motivations, or values, cannot be observed directly, but can be studied using indirect methods developed by researchers. Realities that cannot be directly or indirectly subjected to sensory experience, such as the existence of heaven or divine rewards, fall outside the scope of the scientific method. Another key characteristic of scientific method is that it is verifiable. Observations made through the scientific method must be verified or disproved through further sensory-based testing. These verifications can be carried out by the same researcher or others. When multiple researchers achieve similar results using the same methods, the findings gain credibility. This replication process reinforces confidence in the researcher's scientific validity. As a result, revelations and intuitions are excluded from the scope of the scientific method. Scientific method has another key feature, that is, being cumulative before beginning a study. Researchers review existing literature to avoid duplicating previous work. Rather than repeating what is already known, they expand on the current body of knowledge. Research findings are systematically organized and connected to earlier studies, contributing to the overall growth of knowledge. This approach ensures that each generation builds on a strong foundation of existing understanding, enabling knowledge to evolve and progress over time. Deterministic, this is another important aspect of scientific method. Science assumes that all events have identifiable and logically understandable causes. Scientists believe that nothing happens without a reason. Their goal is to explain phenomena by uncovering these causes. For example, if many students fail an exam, researchers might examine factors like teaching quality, curriculum, student preparation, or administrative challenges. They strive to pinpoint the most significant causes to suggest practical solutions. This reflects parsimony, emphasizing simple explanations with the fewest variables to address the problem effectively. Ethical and ideological neutrality, conclusions from data analysis must be objective and grounded in factual evidence, not influenced by personal opinions or emotions. For instance, if a hypothesis suggests that increased participation in decision-making enhances organizational commitment, but the results do not support this, the researcher should not argue otherwise. Such arguments would reflect personal beliefs rather than evidence-based findings. Researchers, being human, may have personal ideologies, cultural ties, or biases that could affect their work. To ensure data integrity and valid predictions, researchers must stay objective, maintain neutrality, and present unbiased results.
Let us summarize now. In this topic, you have learned that the scientific method is a systematic approach to investigating the natural phenomena through observation, experimentation, and analysis. It minimizes bias by relying on empirical evidence and replicable procedures. The method involves forming hypotheses, testing them, and refining the theories based on the results, ensuring objectivity and its reliability. Thank you. Happy learning.